Oh, nice piles, people. Oh my gosh. This is a disaster. The whole purpose of this was so they'd be easier for me to organize. All right, so here we go. We are looking at review sheet 5.1 to 5.4. So we're just going to start at the top, get out a sheet of notebook paper. Get out a sheet of notebook paper, and here we go.
You're recording?
Yes. All right, so we start out here with a couple of just basic arithmetic issues. How do we take care of expressions that look like this? Because we know as we go through our identities that we're going to run into places where we need common denominators or where we need to clean up big fractions. So our common denominator is going to be xy. So this one needs a y and this one needs an x. So the answer will be 1 fraction over xy, cy minus dx over xy. That's all there is to it. You've been doing that the last few days with sines and cosines and stuff like that, right? Now, here we go. What a mess. This is a big fraction that has some little fractions in it. I'm going to multiply through by xy. You can do whatever you want, but I choose, it's just easier for me, and it's flat out faster than anything else you could do. I'm going to multiply everything by xy. Every term by xy. So what will that leave me with? X squared y plus y squared x
over 2
over y plus x.
Yeah.
Now usually, not always, but usually at this point, there's some simplifying that can be done. Not always, but usually. So look at the numerator. Is there anything at all I could do with the numerator?
Take out a y.
I could take out a y and an x. So if I take out an x and a y, what would I be left with? Now I took out an x and a y. So all that's going to be left is an x plus a y. And lo and behold, what's on the bottom? X plus y. So what's going to happen? These are going to cancel, and our answer is just xy. These are not fractions. It would cancel if I were multiplying xy times 1 over x. But I'm just multiplying xy times x. Nothing cancels. Down here it did because they're in the denominator. See it? Okay. Now, the next ones, in that same section, number 1, the next ones, you're doing the same thing, only you're doing it with your trig functions. So, Cassie, we look at that, and the very first thing our beady little eyes notice is that right there. What do we know about the sine of 90 minus x? It's cosine. That is one of your co-function identities. So now I have secant times cosine. Wait a minute. What do I know about secant and cosine? They're reciprocals. And what happens when you multiply reciprocals? You get 1. So that one simplifies down to just 1. All right. Oops. What about this guy? Now, as I wrote it, my heart started beating a little bit faster because what do I have?
Sine squared plus cosine.
I have a sine squared and a cosine squared, which I know is 1. So I have 1 plus tangent squared. Now you got to be getting goosebumps there. What's 1 plus tangent squared? Secant squared.
So it's just going to be
So we have secant squared over secant, which is just secant. Now those of you that are lost, what are you doing? I have no idea. You haven't memorized your identities because that's all we've done. We've taken sine squared plus cosine squared and replaced it with 1, and then 1 plus tangent squared is secant squared. Right? There's nothing to understand here. You either have memorized your identities or you haven't. And if you haven't, you can't do it. All right, next. One more. All right, what do you want to do with this guy? What do we often do when nothing else strikes us? We change into sines and cosines because they are kind of the commonality that all the functions have. All of them can be written as some form of sines and cosines. So when I see secant squared over tangent squared, that's nothing. I mean, there's nothing that I know that is. So I'm going to try to simplify that. So what's secant squared? 1 over cosine squared. And what is tangent squared? Sine squared over cosine squared.
Could you multiply that?
So instead of, this is a big division, so when I divide fractions, I multiply by the reciprocal, right? So those are going to cancel, and this is 1 over sine squared. So it's 1 over sine squared plus, out of order here, 1 over sine squared plus another 1 over sine squared. So what is that? 2 over sine squared, which you are welcome to leave as 2 over sine squared, but you could also write that as 2 cosecant squared. Because what's 1 over sine? Cosecant. So this is cosecant squared, that's cosecant squared, add them together, get 2 cosecant squares. What did I say? I said you are welcome to leave it that way.
Well, thank you.
All right, number 2, part 2. All right, so those directions were simplified. So all we did was break it down. I think these are harder than the proof ones because these you don't have an end point. You don't know where you're going. You just keep going. Down later we'll do some proofs. There's some proofs on here. But first, we're going to go in order. So we're going to do number 2, which is a whole different kind of problem. It is a solve problem. So we are going to solve, and the directions are these. Notice this is part 2. Notice part 3 is also a solve, but what are its directions? 0 to 360. Now, this means we're going to solve this group, we're going to do in radians, and the other group we're going to do in degrees. Okay, I'm going to do this this in radians. Oh boy, here we go. Your answer to these questions, these solved questions, will not be something like this. Your answer will be x equals pi over 4 or x equals 60 degrees. That's what we're shooting for, an actual x equals answer, because this is an equation. All right, so what's your thought on how to get it started?
You can take a sign out.
You can take a sign out. So I'm going to factor it out. What does that leave me with if I factor out a sign?
Cosine, or 2 cosine.
2 cosine minus 1.
Now that's a double identity, right?
Actually, it would be if it were squared. You're right, it could be, but it's not squared. 2 cosine squared minus 1 is an identity, but that's good to be thinking about those identities. What do I do once I factor in an equation like this? Set them both equal to 0. So sine x equals 0, or cosine x equals 1/2 if I work a couple steps there in 1. That is not the answer. What did I tell you the answer is going to look like?
You gotta find the angle.
Gotta find the angle. So I need to find the angle where the sine is 0. Do you remember you're going to look around the circle for that? It's quadrantal. Kids, if you tried to build a triangle, the opposite side would have to be 0. That's not possible, is it? So that's why we know we look on the circle. Now, where around the circle would y over r be 0? Where does that happen? It happens right here and over there. So in radians, what are the two answers to that question? X equals 0 and pi. Remember, these directions told us that we are answering in radians. You know how to do that. Got to do the other one. We are not done. I was just erasing, right, to make a little more room. I need to do this. Now, can I make a triangle when it's a 1/2? Definitely. Here is the big question. Where will the triangles be? Certainly quadrant 1. Anytime you have a positive value, it's going to be in quadrant 1. Where else? Jason's up here going like this. He's right. In quadrant 4, the opposite side would be negative, but not the adjacent side, right? We're going all the way around. So we got to get all the places where the cosine can be a positive 1/2. Now, how big is this angle right here? It's 60 in degrees, it would be 60. I need you to think it backwards. How many radians is 60?
What is that?
1/3 pi. Now, how did he do that? 180 is pi. 60 is what fraction of that? 1/3. So that angle is pi over 3, so is this one. So another answer to the question is pi over 3. What is this angle? This is your other angle. What would it be, Rachel?
At the top, doesn't it say solve between those two? So wouldn't it be 0 to 180?
2 pi is 360.
Pi.
Would you say you're right?
5 pi over 3.
No, 5 pi over 3. What's all the way around, Rachel? I just told Rachel, what's all the way around? 2 pi minus 1/3. What's 2 pi minus 1/3? What's 2 minus 1/3? 1 and 2/3, which is 5/3. Right. So there are the 4 answers to this problem. We get to do 2 more. This one will be easier though. Tangent squared equals 1. How do you want to solve that guy?
We'll put the one on, I'll subtract the one, we'll put it equal 0.
You absolutely can. What else could you do because of the way this problem's structured? You could actually square root both sides if you wanted to. You can do what you said, subtract 1 and factor. You might just take the square root of both sides, so tangent equals, watch it now, plus or minus 1.
Alright, this is square.
Alright, now we are in radians, and that's okay, but first I gotta figure out where can the tangent be either positive or negative?
1 and 3.
Now that's where it's positive. Where's it negative?
1 and 2.
Can't be negative in 1.
2 and 4.
2 and 4. So we're looking at answers everywhere. Isn't the tangent either positive or negative everywhere? I mean, it's either positive in 1 and 3, or it's negative in 2 and 4. So we're everywhere. And what kind of triangle has a tangent that's 1? 45. Now, how many radians is 45? In other words, what fraction of 180
So
is 45?
1 over 4 pi? Or 1 pi?
1/4 pi, pi over 4, yep.
Yeah.
These are all pi over 4s. So what are our answers?
Pi over 4.
One of them's pi over 4 for sure. That's this one right here, pi over 4. Now we want to go all the way over to here.
That would be.
So we would do
3/4, 3 pi over 4. Jack, how did you figure that out so fast?
Because 1 minus 1.
Exactly. This would be 1 pi, right? So he said if I took away a 4th, that would leave me with 3/4. We'll do the same thing here, only instead of taking it away, you're going to add it. So that would be 5/4. And then what about the one all the way around, which is all the way around except a 4th? 1 and 3/4, which we normally write as 7/4.
Now, aren't all these going to be plus or minus?
If you take the square root of both sides, it's going to be plus or minus.
So, you just leave them like that then?
That's the answer. That's what you leave up there. Those are the answers. The answer is x equals. Okay? Now, if that confuses you, I thought this would be easier, but if it confuses you, go ahead and get the 0 and then factor it into tan plus 1, tan minus 1. See what's going to happen? You're going to get tangent equals -1 and tangent equals +1. So it's all going to come out the same. And it does not make one bit of difference. Do it however it makes sense to you. All right, one more of these, and then we move on to the degrees, which are done the same way, just in degrees. All right, what do you think about this guy? Do you notice anything about it when you look at it? Does anything occur to you?
Yes, it has factors.
What, somebody said it? It factors. This is a quadratic equation. It factors. Cassie? Can you see the factoring? How does it factor?
Or minus.
Okay, is she right? She's got a little bit of an issue. It's got her signs wrong. Yep. And you would catch that when you foiled it, which you would do to check. You would do outsides and insides and make sure you got your -2. Which means sine equals -1 or sine equals 3. I don't know if we've talked about this or not. That's 3/1. That would mean opposite over hypotenuse is 3/1. That would mean your triangle would look like this. Can't have that. This is an extraneous root. Sine cannot be 3/1. Because what do you know about right triangles? Hypotenuse must be bigger. So you can't have 3/1. Does that make sense to everybody? So when I solved the equation, that's how it came out. That's great. No answer to that part. This part has an answer though. Where does the sine equal -1? In other words, where does it happen that if you put y over r, that's what sine is, y over r, that you would get -1? Where does that happen? The bottom. What angle is that in radians?
270.
Well, it's 270 in degrees. 1.5 pi. The only answer to this problem is 3 pi over 2, 1.5 pi. Because the other place we might have gotten answers was extraneous. Okay, now part 3, it says we're going to use a calculator on this part. So if you have your calculator today, God bless you, get it out. If you don't have your calculator today, we're looking for answers all the way around. We're going to be in degrees, so make sure your calculator's set in degrees. And the first equation says this, divide by 2. So cosine x equals 0.185, is that right? I think. How do I go about solving this? Before you press a button, I want you to think about something. Where are these answers going to be? Remember, your calculator will only give you one answer, and most of these problems have more than one answer. So where will I look for angles that have a cosine that's positive?
In the first quadrant.
In the first quadrant and fourth quadrant. To find this angle, this is not like root 3/2 and stuff. I need my calculator to find that angle. What buttons do I press? Second cosine, 0.185. And that angle is 79.3. Give me rounding directions. No, of course not.
So then you do 360 minus 7.
So one of my answers is 79.3. And Brenton, you're exactly right. The other one is going to be 280.7. How did we get 280.7? We did 360 minus 79. Yeah.
How'd you get 79.3?
Second cosine 0.185. How do we find angles? Second whatever. In this case, cosine. That's always how we find angles.
Can you take out the tangent from this one?
Yeah. This is a little quadratic. It's already set equal to 0, but Brenton has observed it's factorable. He said take out a tangent.
Now, but you can't have 10 x equals 0, right?
Yes, you can. Now, you can't have it in triangle form, but you sure can have it on your circle.
Oh, right.
Where on the circle does the tangent equal 0? Okay, so we're moving along here kind of fast. Took out the tangent. Left me with this. Right? So I said each of those equal to 0, so this one would say tan x equals -4. You cannot build a triangle where the opposite side is 0. It would have to be opposite over adjacent. That doesn't make sense. So that's happening somewhere on an axis. Tangent is y over x. Where does it happen that if you put y over x, you get 0? Up here?
Yeah.
Whoa, 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 what happens up here if you put y over x?
Undefined.
Undefined. That's not 0, that's undefined. What about here?
Yeah.
If you put y over x here, don't you get 0?
Yeah. 180, right?
So your answers would be 0 and 180 to the first part of the problem. Now, where does the tangent equal -4?
All except the second.
It would be, tangent would be negative in quadrant 2, right? Because it would look like this. Where else? Quadrant 4, because it would look like this, right? Now, this is why we need a calculator. Do you have those numbers memorized? Do you know how big that angle is? No, if they were root 3s and 2s and stuff, you'd know it was 60 or 30 or something. You don't have a clue what that is. So we're gonna use our calculator. This time, Brooke, it's second tangent. And I got 70, actually about 76. I'm just gonna round it off to 76. So that angle is 76 degrees.
360 minus 76.
76 is not an answer. The answers
Oh, 180.
are this,
180 minus.
which would be what, 104? And this, which is what, 284? And there are the answers to the question. So even though we use our calculator, we still have to know a lot. We still have to know where to draw the angles. We still have to know how to factor the equation. I mean, there's still a lot to know. Okay, one more. You could subtract the 5, but since 5 is really not a nice number, I think I'm going to square root both sides here. The other one we had, it was okay because it was like a 1 or something. This one, I'm just going to square root both sides, and it's going to say cosecant equals plus or minus the square root of 5.
Yep.
Now this is a little bit of an issue because I don't have that button on my calculator, right?
So you gotta change.
So I gotta change it to a sign. So if the cosecant is plus or minus the square root of 5, the sign will be plus or minus the square root of 1/5. Now this is another one of those plus or minus deals, kids.
So it'd be in all the.
So it would be in all the quadrants. You are either positive or negative. If you are a sign, you're either positive or negative. You're positive in 1 and 2, and you're negative in 3 and 4. So I need that angle. So again, I'm looking for an angle. So it's second sine square root 1/5. And I got about 26.6. Tell me if that's what you got. You may match that?
Yeah.
So what are the answers to the question? One of them is 26.6, so I'll write that one down.
No, 180 minus 26.
180 minus 26.6. Everybody see it? That would be that one? Which would be what?
153.43.
Thank you. 153.4. I'm rounding to the tenths just randomly, so yeah, you're fine.
No, 180
180 plus
plus 26.
that, so I can do that one, 206.6.
Yep.
And then the last one all the way around would be
333.4.
3 what?
333.4.
333.4. That about right? And there are your 4 answers. Everybody excited about that? Well, what you're excited about is look at the next section. This is what we love. And as you're watching the clock, counting the moments till you can run for your lives, remember what I am doing here. I am doing your homework for you, right? Yes, you're welcome, Brenton. So try to stay focused and pay attention. Here we go. Wow. Wow, this scares even me. Actually, I'm not scared, I'm invigorated. This looks like a good one. Let's see what we can do here. Any thoughts?
Can you get comment?
What an obvious thing to do. You have 2 fractions. Now, Brenton, that is not to say that's the only thing I could do, because there are other things I could do. But it makes sense, just get a common denominator. So the common denominator would be secant minus 1, secant plus 1.
Would you not factor together?
I maybe eventually will, but right now I'm just writing my fraction. So that's going to be my common denominator. So this one needs a secant plus 1. And this one needs a secant minus 1.
So it would be 2 secant.
So on top, I'm going to have secant plus 1 plus secant minus 1. Yep, you're ahead of me. The ones are going to cancel. So I have 2 secants over secant squared minus 1 if I collect like terms on the top and FOIL out the bottom. Now it's good to see a 2 because we need that, right? Let's see. Let's see. Alright, wait a minute. Secant squareds and 1s. I got some kind of identity, but I have to write it down. That identity is 1 plus tangent squared is secant squared.
So then you're gonna, so
So subtract
subtract 1.
1 would mean tangent squared equals secant squared minus 1. So I have a secant squared minus 1 in my denominator. So I can replace it with tangent squared. So now I have 2 secant tangent squared. Now what do we know about tangent? It's the reciprocal of the cotangent. So this is 2 secant times 1 over cotangent squared.
Tangent's on the bottom.
Look, right?
It's not
your 4th step.
What?
2 secant x, tan square should be below that, right?
Oh, yes, yes, thank you. Thank you. No, I'm sorry.
It's on camera too.
Yeah, that's okay, I'm not perfect. That is, not even close. That, besides, I had chemo yesterday, so I'm alive.
That's fair.
Secant squared minus 1 is in the denominator, so my tangent squared is in the denominator. So what I have here is 2 secant times 1 over tangent squared. That tangent squared is in the bottom. See that? This was in the denominator, so I wrote it in the numerator, and it has to stay in the denominator. So I have a tangent squared in the denominator.
But isn't there a reciprocal of tangent?
Yes, but I'm trying, so we're going to see that right here. That is a tangent squared in the denominator, which is just going to turn into a cotangent squared in the numerator. Because since it's in the denominator, it's really a 1 over tangent squared, and 1 over tangent squared is cotangent squared, which is what we wanted to end up with. Alright, so let's go back through that since I messed it up. First thing we did was get a common denominator, so that gave us this. The ones canceled, leaving us with 2 secant on top and secant squared minus 1 on the bottom. Secant squared minus 1 is the same as tangent squared from that identity right there. A tangent squared in the bottom is like a 1 over tangent squared, which is a cotangent squared. Awesome. All right, let's see what's next. I think we've done this one before. Or at least it looks really, really familiar.
Could you just change tangent to sine?
I would definitely do that. Change tangent. Now, be careful. I know there are identities to get from tangents to secants, but if you're, it's the one I just erased, but they're not squared. So there's no way to do that. So your best bet is to write as sine over cosine and cosine over sine. And of course, this is what I keep harping at. Do not think you have to have the vision of the whole proof at the beginning. You don't. Do something. Because usually when you do something, the next step becomes clear. Now you have a fraction plus a fraction. So what are you going to do next? You have no idea where it's going to take you, but you know you can get a common denominator, right? So we'll multiply this one by sine and this one by cosine, so that we have in the denominator sine cosine, one denominator. The denominators are the same.
So then it would be sine squared plus cosine squared.
Bingo, look at that. And of course that is just 1.
Then 1 over.
Now, can I split that apart and say 1 over sine times 1 over cosine?
Yeah.
Are these two the same thing? Yes.
And then you would just.
You can do anything as long as they end up being the same thing. David, are you paying attention? No, you're not. Okay? Try. Go hard. I know there's probably a zillion places you'd rather be. I don't understand that, but I think it's the case for you. Right now, we're here and we need to be focused. All right, 1 over sine times 1 over cosine. Does that bring us what we wanted?
Yeah.
Yeah, so we're done with that one. All right, one more of these. All right, any thoughts on this one?
Well, I say we do the first thing that's go right because we can change 1 minus sine squared to cosine squared.
Okay, so Brenton says, look at that. That pops out at you because you know 1 minus sine squared is cosine squared, and cosine squared times cosine is cosine cubed. That one was worth the wait. That was so easy. Good job. All right, let's get a few more done. There's a lot of problems on this guy. Let's get a couple more done. All right, so we're going to find the exact sine of 15. Okay, so one option, the first one I heard, is 45 minus 30. There are many other options. Everybody agrees with me, right? You just pick one that when you either add or subtract, you get 15. Now I need my formula. No formulas will be given on the test. Now Mrs. Ford was extremely nice on the quiz, because that's me, extremely nice. Huh? I gave you the formula. I'm
On the
sorry, I
quiz?
gave you the formula. Yes, I did.
Oh, and you had to figure it out.
This one will not, no formulas on the test at all. So you need to know that sine 45 minus 30 is sine 45 cosine 30 minus cosine 45 sine 30. The formula for the sine of an angle minus an angle is sine of the first cosine of the second minus cosine of the first sine of the second. Here we go. I need to plug some numbers in here,
So it's gonna be root 2.
and these numbers are going to come from my special triangles, right? But Brenton says, this is for, we have done this ad nauseum. I know that the sine of 45 is root 2 over 2, and the cosine of 45 is root 2 over 2. I don't need to draw that one. I know that. I do it over and over and over again. Now, he may also have the 30s memorized, but I suggest you go ahead and draw that one so you don't get them mixed up. The cosine of 30 is root 3 over 2, and the sine of 30 is 1/2. If you have those memorized, I am perfectly okay with that. But it's easy to get them turned around with the 60s, so I would probably draw it.
So it would be root 6.
Anyway, yep, root 6 minus root 2 over 4. And when you did that problem on your quiz, and it wasn't that exact problem, but when you did that kind of problem on your quiz, you got an answer that looked an awful lot like that, or you should have. Because all of them look like that. Some version of this. All right? Let's see if we can get this section finished off. Here we go. Tan 75. Now, these are the harder ones because tangent, just the formulas, just always cause arithmetic issues. But let's get it started. Tan 75.
45, 30.
Probably a very safe move would be to use 45 and 30. There are other options, but this is a good one.
So tan 45.
Formula says, yep, tan 45
Tan 30.
plus tan 30 over 1 minus tan 45 tan 30. Now I'm leaving my 30 picture there because I need it. Do you remember what the tangent of 45 is?
1.
It's 1, because opposite and adjacent are the same. So I'm going to plug in the numbers. I have 1 plus. Okay, what's the tangent of 30?
Is it 2?
It's 1 over root 3, which is root 3 over 3. Kids, look, opposite over adjacent. Over 1 minus 1 times root 3 over 3. Everybody with me here? Now that's a mess.
Times 3.
So I'm going to multiply everything by 3. You can do whatever you want. This is what I recommend. So now I'm going to have 3 plus root 3. Remember, the reason you did this, kids, is to cancel those. That's why you did it. So you have 3 plus root 3 over 3 minus root 3.
Then we get rid of the denominator. You do 3 plus root 3.
Now we got to multiply by the conjugate of the denominator. So we're multiplying by 3 plus root 3. And we're just going to FOIL now. FOIL, FOIL, FOIL. So the top if you've done this homework assignment, you've already done some of these.
It'd be 12 on the bottom.
No, it'll be 6 on the bottom. Because it's 9 minus 3. It'll be 12 on the top. That's on video. But it's okay because you're not perfect either. Closer than me though, closer than me. Alright, so what do we end up with? Divide everything by 6. Remember your triangular cancellation just like we had before with the quadratic formula. So we're going to end up with what? 2 plus root 3 as the answer to the question. 2 plus root 3.
There we go.
Alright, we got one more to go. We're doing great. Okay, this one's different now. This one, I'm finding the cosine of 2x, and I know that cosine is 4/5, and it's in quadrant 4. So this part is the given, right? What does it help me with? It tells me where to draw the picture and how to label it. So I'm going to draw my butterfly bow tie in quadrant 4. And the cosine is 4/5, which means by the Pythagorean theorem, 25 minus 16, that's going to be -3. I wish I could just show you what you look like right now. Cosine 2x. Here we go. I know it's long, it's long, it's long. I know. Cosine 2x. You got some formulas. I don't care which one you want to use. Which one you want to use. There's 3 of them. Does not make a single bit of difference.
Is that the double identity?
It's a double angle identity. Cosine squared minus sine squared is the one we use most often. Look at your picture. What's the cosine? 4/5. We need to square it. So we get 16 25ths. What's the sine? -3/5. We need to square it, so we get 9 25ths.
Would it turn into a box?
No.
Because
But that negative is getting squared out. So you actually have 3 negatives. You have minus a negative negative. Do you see what I'm saying? So what's the answer to the problem? 7 25ths.
Yeah, step down.
Tomorrow, or I guess Monday, we will pick up right there. Ooh, it ran off the page. I'll have to see if I can find those. I don't know if I can or not. And we'll pick up right there and finish this sheet. Answer any homework questions. Oh, actually, since it's